So let's say you're given a field, and field is, its height is 2 and width is n. So this is 2 and this field is of a variable width n. You want to cover this field with few tiles. You are given few tiles and tile is 2 cross 1. So 2 is the height, 1 is the width of the tile. This tile you can rotate and keep it horizontally also. So it's 1 cross 2. You can keep it horizontally or you can keep it vertically. You want to cover entire field and you have to tell how many different arrangements are possible. So it is about number of ways to cover field, to cover 2 cross n field with 2 cross 1 tiles. So you're looking for arrangements and patterns. So if we just talk about, let's say if you have n as 2, if n is 2,
So I have a solution in mind. May I try?
No, not solution right now, because I want people to think about this also. Then we will discuss Prakash
Okay.
solution.
Okay.
Let's treat
Yeah,
this as a thinking
I'll work
exercise so that people can work out. So when n is 2, there are these two arrangement possible. This is first arrangement. You can put 2 tiles vertically, or this is the arrangement. You can put them horizontally. For n is equal to 2, answer is 2. If n is equal to 3, can you work out the answer yourself and tell me? If there was field was of length 3, how many unique arrangements of the tiles you are finding? Can you work out? And first we are trying to understand the problem here.
Three arrangements will be there.
How can you speak up, Prakash? What are your arrangements coming?
3 verticals.
3 verticals. Okay, so first vertical, second vertical, third vertical. Arrangement A.
Yeah.
Okay. Second
then
arrangement.
2 horizontal, 1 vertical, and then 1 vertical, 2 horizontal.
Okay, so 2 horizontal and 1 vertical. So this is your arrangement B. And C arrangement, you are saying 1 vertical and 2 horizontal.
Yeah.
Okay, there is no other arrangement possible?
I don't think there is.
Okay, anyone else? How many arrangements others are getting? Prakash says 3. I just
3.
want, okay. Vinil says 3. Anil says 3, okay.
Yeah, 3.
Okay, 3. Okay, now you understand the problem. Work out the recurrence for this. And in that recurrence, keep in mind your height is fixed to 2. So 2 doesn't have to be a member in your function. So problem statement is you are given a field of n width, 2 height. Tiles, infinite supply of tiles is given. You have a lot of tiles available to you. You have to cover the entire field, but you have to tell how many different arrangements are possible.
Sir?
Yeah.
There are 2 vertical and 1 horizontal, right? So will that also be equal to
so
vertical,
if
horizontal, vertical?
Kushmita, if field is of length 3, can you really put 2 vertical and 1 horizontal? That will go outside the n range, right?
Outside the, okay.
So those arrangements are not valid. If you put 2 vertical, horizontal is not possible because its height is 2. You cannot break the tile. You have to cover entire field without breaking the tile.
Yes.
Of 2 cross 1 tiles that can be kept horizontally or vertically without breaking the tile or leaving any part uncovered. How many different ways are there to cover the field? Okay, I would want to hear response from anybody who has not spoken till now or who have not been able to work out the previous problems. Okay, Ram, can you give your recurrence?
Yeah, it is W of n is equal to W of n minus 1 plus W of n minus 2. And base is n of 1 is equal to 1, n of 2 is equal to 2, n of 3 is equal to 3.
Base of 1 is equal to 1.
1. N of 2 is equal to 2.
Do
Sorry,
we
3.
really need?
N
No,
of
for
2 is,
2 it will be 2 only.
yeah, so n of 2 is equal to 2.
So base of 3, we don't need that as a base case because 3 can be
Yeah,
calculated using this, right?
Yeah, correct.
Okay. So everywhere it is Fibonacci only, right?
Yeah. So what I felt is like even though like we can reduce it to a means like it is a way to we cannot say like, oh, this is falling into Fibonacci, so this is Fibonacci, but like once we find out like, oh, this is falling into that, so that is a way just to recalculate saying like, oh, we are going in the right way.
Correct. That's right. Actually, Fibonacci is very, very important. It has a lot of applications and all these things that we are seeing. Many a times, different contests will have problems. And when you actually drill deeper into that, when you start working out the pattern and say, hey, this is nothing but Fibonacci. So, but some clever people would modify. We will go to 2 more problems today we will do so that you broaden your ways of thinking. And they will not be Fibonacci. They will be little modification of Fibonacci.
Yeah.
Okay, cool. So this is done.